world of NDE 4.0. My name is Johannes Vrana, and today I have three great guests with me. Now, for those who are new to this channel, if you haven't subscribed, then click on that button now. And if you haven't clicked on like, then do it now. Now, during this video, you have the opportunity to ask all the questions you want to ask. And now I have to... Oh, sorry. There was some... I have to stop something very quickly because I'm hearing myself about 1 minute early. Very sorry. That's what happens with live events. So, yes, today you have the chance to write anything in the comment section or in those questions you want to ask us. So feel free to do that. We might not be able to answer all your questions right ahead, but we will try to answer them later, either in the video or we will upload some answers to your questions after we have finished the video. Now, I think now it's time to introduce all my guests. Now, so today we will be talking UT. We will be talking ultrasonic testing. And you know that on this channel, I've been doing two kinds of videos. On the one hand, I've always been doing all those NDE 4.0 videos. And on the other hand, I've been doing all the UT videos. So UT is really the method I know best of all. And the company which comes to my mind, speaking about ultrasonics and NDE 4.0, is UTEX. And I have to say, I purchased my very first license for UTEX inspectionware back in 2011. And that software has developed by a lot from back then. But already back then, it was kind of a big step towards NDE 4.0. Now, you all know me. I'm a physicist. I've been working for, I don't know, something like 15 years on ultrasonic testing. I did my PhD on thermography, and since about 2017, I've been more and more working on NDE 4.0 and trying to bring NDE 4.0 to all of you and to supporting our customers to get started with NDE 4.0. And the guy who's helping me with getting people started with NDE 4.0 is my dear friend Ripi Singh. And Ripi, can you introduce yourself a little bit to the audience?
Absolutely. Thank you, Johannes, for inviting me to be on this interesting conversation about UT and its future, along with the esteemed scientists from UTEX. Good morning, good afternoon, good evening, wherever you are in the world. I'm Ripi Singh, a former professor of aerospace engineering, a former technology executive with UTC and Alstom Power, and now a practicing innovation coach for the last 10 years. I met Johannes about 6 years ago, and since then we have been dabbling and learning about digital transformation, helping our clients build the roadmap and get on this journey that is going to be very, very exciting for most of us at this point. Thank you, Johannes.
Thanks, Ripi. So next up, Abhishek. How did you get to the world of UT and NDE 4.0?
Well, it's been an interesting journey. My fascination with ultrasound began when I started my doctoral work. That was a couple of decades ago. And that's when I was experimenting with ultrasonic attenuation spectra for measuring particle size distribution in suspensions in real time. So that was a lot of fun. But these days, I create applications for analyzing ultrasonic data. And I have also developed and deployed automated NDE inspection systems in the power generation and aerospace sectors.
Thanks a lot. So, last but not least, Dave Seto. How did you get to UTEX? What was your process? How did you get to NDE 4.0?
Was dragged into NDE backwards through the hedge. My previous career was in chemical processing. I'm a chemical engineer by trade and by nature, I suppose, as well. I had reached out to Walter Weber, the founder of UTEX, to help with a translation of a German paper involving the I knew Walter socially, involving the ultrasonic monitoring of thermoset resins, and I was managing a thermoset manufacturing operation. So we got chatting, and we devised a mechanism by which we could do online real-time monitoring of this thermoset process, this resin manufacturing process. It was a tiny amount of money, and the company that I was working for was absolutely not interested. So I left and went to work for Walter. So there I am. And then, obviously you can't work for an ultrasonic and software company without having to leave your chemical engineering career in the background. And then with NDE 4.0, we have always been advocates for automating those parts of the process that need to be automated to reduce the potential for error, to reduce the amount of tedium that an operator has to go through. You should not have to manually calibrate 8 channels to inspect a titanium billet or something like that, right? That's what computers are for, is to make that process go from a couple of hours down to a minute or 2. So we've always been advocates for that. And along the way, we've learned a lot from the people who do that kind of work, what tools are useful, what tools are not, and maybe that's one of the things that we can discuss today.
So welcome to all 3 of you to the channel and to this live webinar. So first question to Dave. So for you, how does the future of ultrasonic testing look like?
Ultrasonic testing is a small word or a small phrase for actually a very big and varied field, right? So you have in-service inspection, and you have inspection of complex components during manufacturing, and you have ultrasonic testing that has a very low complexity, and then you have ultrasonic testing that has huge complexity and needs nearly PhD level physicists and data scientists to figure it all out. But all of it is being driven by the usual economic drivers, right? We want things done faster, we want them done at lower cost, we want them done at higher quality. So all of that points towards increasing automation. One of the things we see, because we're one step away from the pointy edge of the NDE business, so we don't do inspections ourselves, but we build tools for people who do. There's a big demographic shift, and people have been talking about this for at least a decade. The tribal knowledge that we have in people who are reaching retirement age is dissipating as they all retire out of the industry, and recruitment has been fairly difficult using this sort of traditional pathway into the non-destructive testing business. And maybe because I came at it from a different pathway, I might be more able to see that. But one of the things we do is work really hard at getting young people involved in the industry. And my favorite way to do that is through the angle of the software and the digitalization and that avenue, as opposed to the direct tools like the ultrasonic probes and how you do those kinds of inspections. I think more and more, especially in manufacturing, and I'm also seeing now increasingly in service inspection, there is a virtualization, or as you say, a digitalization of the entire industry. And I think it's at its beginning now, but you can see very clearly that more and more companies are entering the market with digitalized NDE tools, right from sort of completely virtual 3D, augmented reality simulations to train people, and then you can use those same simulations to analyze data in 3 dimensions in a very intuitive way, right? The visualization tools are getting better and better, and we're absorbing more tools from other industries. So the future is very exciting. Actually, I'm looking forward to seeing what's next.
Yeah, I see with especially with ultrasonic testing, we have been using it now for a couple of decades. And we know it's working on a lot of components, and it's giving us really good results. We can inspect huge components made out of steel and see the tiniest imperfections in the middle of it. But what I see is that in a lot of places, especially ultrasonic testing, you get a signal and it's easy to write it down and to do something with it. But for me, there is also this huge step. We need a better understanding of what the signal we are getting back really means. Because I think, especially with ultrasonic testing, when I see a fractal mechanics specialist talking about UT and a UT guy speaking about UT, and one guy saying, oh, I found a group indication, the UT guy, then the fractal mechanics guy thinks, okay, this is now something where I have some structure in the material. But then finally you cut it open and you see, oh, that single indication has about the same material pattern, then because we are talking about different scales. So I think, especially with ultrasonic testing, there is still a lot of room for better understanding actually the methodology, going to more simulation, actually perhaps using digital twins to support the inspections, to get a better understanding of our results.
Yeah, I agree. It's I forget who told me, but they said all the low-hanging fruit is gone. So big stinky cracks, surface breaking defects that you can see with the naked eye, right? Our manufacturing processes have improved significantly, right? Our quality control is so much better because of manufacturing 3.0. Everything's been computerized that we can. And so our ability to manufacture extremely high quality materials and to assemble things in a way that's extremely reliable is there. So now what we're looking for is like you say, those tiny defects. And as we were talking about just before we went live, there are things that we can see in the image that we don't even understand whether or not they're a defect. And it might take 20, 25 years for that indication, that change in the pattern of the material to actually manifest itself as a defect and then catastrophic. So that's where I think all of the exciting stuff that's going on in R&D and ultrasound is characterizing materials as opposed to finding defects, and characterizing that material as this one is going to have a low risk in 20 years. This particular pattern is going to have high risk in less than 20 years, and then you can do something. You can plan for life extension, or you can plan for repair, or you can just not use that component.
So that's very interesting what you just triggered, Johannes. I come from fracture mechanics, computational simulation side of it. So if we can simulate fracture mechanics and simulate the response of an ultrasonic wave through finite elements and actually generate maybe surrogate response services for various characteristics of flaws, then with augmented reality coupled with finite elements simulated response surfaces, you can actually visualize the defect with so much more precision, so to say, with ultrasonic that is up until now not possible. I mean, it's a combination of 4 different technologies that can come together to really see as if you just made the material transparent.
That's a really good point, Ripi. I think one thing that we tend to not pay enough attention to is that ultrasonic testing is basically the coming together of multiple fields where there are experts that are developing the next generation of technology, and it starts all the way from the instruments themselves. And as our electronic capability develops and becomes better, we're making better and better instruments. As our computational capability is getting better, we are able to gather more and more data. And as we are able to start analyzing this data in a more contextual manner, which comes from where the data was collected, what kind of material it is to begin with, and so on and so so forth. So that gives us a really the ability of really an insight into what could be happening. Now, what could be happening and what is happening are of great importance when you're on the production floor, because doing any kind of testing, especially if you're going to scrap the material, then that has costs associated with it. And that's one place where on one end, you want to be very careful that you do not let substandard material or material that have indications that have the potential of becoming defects onto a component, especially a critical component. But at the same time, you don't want to be over careful and start rejecting material that could have had a perfectly good operational life. So I think that's where, and I think you come from the world of fracture mechanics, so you understand that more than anyone else. Like, there are defects, or rather indications. NDT people don't like calling anything defect. There are indications which start out and are perfectly benign and nothing really happens, but then there are those critical ones. Yeah.
Yeah, and I come from the aging airplane background as well. So, sometimes I tend to miss the intricacies of brand new product while it is still in the manufacturing line, and I tend to fall into there's an old one used and beaten, and how do we actually make sure that it is safe to go? But this is interesting. The other question that I have for you guys from UTEX, you may be aware of it. 25 years ago or so, we were doing SPIR projects on laser ultrasound in non-contact UT. I mean, that, of course, falls into the 2.0 realm. Has that gone anywhere? Is there a future in non-contact UT?
Yeah, absolutely. There are several companies now who are able to manufacture, commercially offering laser ultrasonics. A couple of different methods too. Using small, low-power lasers, which we've gotten better at over the last couple of decades. So you're not actually damaging the material, right? You're creating a small shock wave, a manageable shock wave through the material, and then picking it up with a hydrophone on the other side. So you can do through transmitted laser UT. The old ones, I think you remember, they had like this enormous machine with a Fabry-Perot interferometer, and it was fantastically complicated and difficult to deploy and difficult to maintain and so on. Advances in computing and miniaturization and the ability to make small, cheap lasers is really going to change that industry a lot. We still use, we ourselves have clients using air coupled ultrasound still, because you can get a fair amount of energy into the part, and you get a lot of information, although the image is relatively coarse. That is being improved by this company in Germany called Sonotech, and they make a focused, like a phased array, annular focused air coupled ultrasound probe, which is really exciting. That was presented at ASMT, I think, a couple of years ago. So I think, like all ways of launching sound into a part are valid, and some are useful for some kinds of materials and some kinds of structures, and some are useful for other kinds. But I think all of them will advance. Water coupled ultrasound and non-contact with lasers and non-contact with air. I think they're all going to advance, and they're all going to be used.
Yeah, there is also now that has been also on the market now for a couple of years. There are now tiny microphones.
Yeah.
Or actually optical microscopes where you can listen to the ultrasound.
Yeah. Yeah, I forget their name. There's a Swiss company that makes those, and that's fascinating.
I think it's Austrian, but yeah.
Oh, sorry. Beg your pardon. One of the Germanic European countries. Yeah.
Across
it's
the
all
pond.
Europe anyway.
Yeah.
But that's on the one side, and it's really good that companies are still working on improving kind of the analog part of UT.
Yeah.
And also how we digitize. I see a lot of companies who are now coming up with, instead of just doing an 8-bit digitization, doing 16-bit or 20 or even 32 bits. And I think that will really help also give us more flexibility for what we need.
Absolutely.
But I think between the four of us, that's not what we want to discuss.
Yeah. Yeah. We could do a whole thing on dynamic range and ultrasound. Yeah.
Yeah. I think we want to come to the point where we start with, once we pass digitization, starting with the digitalization.
Yeah.
And we already touched a couple of points like the interaction with other systems. And I think besides now the fracture mechanics, which I think is an important part, because I think a lot of UT is done for components where excessive lifetime calculations have to be performed. So I think this connection is a really important one for the future. But I think there could be another one, and that is, and I want to see how you see that, the connection with inspection planning, with production planning, with feedback on giving feedback with the UT on how good is the product quality, doing perhaps some trending on, do we still have a good product quality, or do they have to change something on the, let's say, heat treatment?
Absolutely. On the the inspection that happens at the OEM level in factories, there is already a trend in that direction. When the NDT analyst detects something has happened to a component, whether it is a metal part or a composite part, the idea is to stop making bad components. So information from this data is extracted. It is put in the context of where did that indication appear with respect, let's say, in case of aerospace composites, with respect to the aircraft coordinates, where did that particular indication appear? And then it goes all the way back to production, because production can then figure out what part of their process, especially if you start seeing repeat indications being caused, what part of their process do they need to fine tune to get rid of these indications? So there is an entire chain of events that NDT indication detection starts triggering. All the way back to production, and at times it goes all the way back to the raw materials, because not everything is built in a particular factory. A lot of things are built in other factories. They're shipped over. They are inspected at the original point of manufacturing, but then when they come in and they start getting formed into shapes that are or machined into shapes that are used, NDT happens at that point, and then once it's mounted or used in a particular assembly, NDT happens at that end. So you can see that at each and every stage that NDT happens, it needs to be all connected, and that's where your digitalization idea, I think, is fundamental to how we can increase productivity and get costs down.
Yeah, absolutely. You have to drive, like, it's already happening, right? People want to drive the cost out of NDT. They want to drive it, to be as low as possible. And that means automation. And that means NDE is no longer something that happens to your part after you've manufactured it. It's part of manufacturing, right? So, we were talking with Ripi about aging aircraft engines. So, as Abhishek said, when you make a titanium billet or a nickel alloy billet, that gets ultrasonically inspected. And then you chop that billet up and you make discs out of it. And then you forge those discs into, engine components or shafts or something. That gets inspected with eddy current and ultrasound and perhaps even X-ray. So then that gets assembled into an engine. And then at some point during the engine's life, it gets torn down and it gets inspected again. And nobody in that chain of events, they're connected to each other economically. But they're not connected to each other informationally. Like the manufacturer of the engine can go back upstream to the manufacturer of the metal and say, hey, can I have the inspection records? But it's a pretty tedious process, and it takes weeks, if not months. And we have the ability now to have that happen in seconds if we want. It's just, we now have the digital infrastructure to be able to do that. It's just that companies aren't perhaps not thinking in that way, that as a manufacturer of an engine, I could have instant access to the the titanium that I'm going to buy and the disc that it gets made out of, and so on and so forth, and the connection of that economic chain into an informational and technical information chain is, I think, the heart of NDE 4.0. Right, like we're at NDE 3.0. Everybody has inspection records. Sometimes, even today, sometimes they're still on paper, right? They're in a filing cabinet. They're inaccessible until somebody sends you an email and says, please dig that out of storage. And more now, though, it's a digital file. It's a CSCAN or a DICONDI file or something like that. And then you can request that, and that's fast. But ultimately, I think people might recognize that there's value in just being able to have a connected network that says, even before I manufacture an engine, I want to know what is the provenance, if you will, of the material and the components that I'm putting into it, and then I'll be able to predict, how successful this engine is going to be.
So you can already see some customer requests to kind of go towards a digital transformation, creating interfaces to their systems.
Yeah, the awareness is dawning, let's say. We have many clients who sometimes don't even know that they're all our clients. So, as Abhishek mentioned, the manufacturer of the material does an ultrasonic inspection using our stuff, using InspectionWare. The processor of that material into an aerospace component uses a customized robotic inspection system with InspectionWare collecting the data. And then they sell that to, let's say, a manufacturer of spacecraft or aircraft or something like that, or a power generation manufacturing company, right? So there are these sort of threads, vertically integrated threads, where people produce material, components are made from that material. Those components are assembled into something that gets launched or has a high penalty for failure, like bridges and power stations and stuff like that. So they're perhaps aware of their relationships with each other, but they're not aware that they all have a relationship with us.
And they are not aware that they actually that they need the EUT data.
Yeah, exactly. And the only time that you sort of hear about it is when people request it because something has gone wrong. Right, like an engine fails in flight is a very common one that you hear about now, because we have instant news, and everybody with a cell phone on that aircraft is now a news broadcaster. So it used to be that you would hear a couple of days later that there was a difficulty and the plane landed safely, but there's no engine on the left side. So but now you're getting it live streamed. So but the information chain is there, and people activate it, and they get the information. But there's a potential to having that information a continuous part of your ecosystem. And it is really mind-boggling to think about the amount of information, the number of digital bits that have to flow back and forth in that scenario. But there's definitely value to it, because as Abhishek said, the goal is to make things perfectly the first time and not suffer any of these kinds of failures.
I wanted to add to something that Dave said. Data means different things to different people. When we utter the word data, an ultrasonic enthusiast like ourselves would think of it as C scans and B scans and A scans, and that's data for us. An analyst whose responsibility it is to figure out if the component is showing any characteristics that could cause failure in the future, or could potentially be a failure point, then that's data for that person. When it comes to the user of these components, or let's take the billet example that Dave mentioned. So as far as the UT that happens on a billet at the metals facility, for them, as long as they're shipping billets out and it has no big cracks in it, that's good enough. When that reaches the next stage of processing, For them, data basically means, is there anything in there? And if so, tell us what you saw, even if it did not meet the threshold for rejection. And that's a useful information, because now you can cut up the billet in such a way that even if even if there were things that could be of concern in a critical zone, in a heat treated zone, then you basically do not keep it there. It's kept somewhere else. So that's what data is for them, like not just is it an indication that will cause outright rejection, and if so, it never makes it to the next stage. But if not, if it does not, if it's not 80%, it's 70% or 60% or 50%, it could still potentially be dangerous depending on where it shows up on the part. So that information is now data, and this is where the definition of data has changed. That information is what's the data point that happens at the next stage of manufacturing. Now, it's in manufacturing facilities where the various steps of processing happen at the same plant or at the same facility. There's a lot of visibility on what's going on and what people have seen. But once it starts getting shipped to other customers and suppliers, that's where this information may or may not make it through. And this happens at every stage. And I think that's where we want to be careful on how much data. It's the useful data that we care about, not the amount of data, but rather the quality of data that matters a lot.
It needs data which, because for in my eyes, UT data, you need a lot of knowledge to do the interpretation.
Right. Yeah.
And that's knowledge which a fracture mechanics colleague cannot have. He has other stuff he has where his knowledge is around. So we have to transfer our result into something which a fracture mechanics colleague or somebody else down the value chain can actually use. Now, Ripi, I have a question for you. We are talking now about kind of that we have with the ultrasonic data, we have something very valuable for fracture mechanics, for other people down the value chain. How can we make them more aware of what NDT could be offering them?
Do we need to make aware fracture mechanics people, or do we need to make the owner operators who are responsible for maintaining the integrity, who have a team of people who may not even have fracture specialists, who are just looking at what the asset OEM gave them in terms of tolerable crack size and detectable crack size? Those people be aware of additional information. In damage tolerance world, we used to say, okay, here is the POD 1995 crack size, and here is a tolerable crack size, and based on those two things, you come up with inspection interval. And fracture mechanics guys have given that to you. Now that becomes a kind of a compliance requirement that you have to stay with it. So the other option would be, if you want to send it back to the asset designer developers, fracture mechanics people, saying, look, the NDE data can be more than just 1995 crack size. We can actually give you this much information. So can you use that to expand the envelope of damage tolerance so that you can expand your inspection interval, and then work with the asset owner operator to see whether you can save on the total inspection program. So there's definitely an opportunity here to engage with the damage tolerance philosophy and see how a larger amount of relevant data can be used to extend the inspection interval. We should put this in front of people at Boeing and Airbus fracture mechanics group and see how they take it.
Yeah. I think that this could even be where perhaps AS&T or some of the other large bodies could play a role, that we perhaps do something like that we approach those. I bet there is also a professional body on the other side, which could help getting some communication started.
Yeah. So the forum for that is the ASIP, Aircraft Structural Integrity Program. They run their own conferences, and when I was working in POD area, I used to go to both ASNT and ASIP conferences, talking the POD stuff to both sides of the equation, to the fracture guys and the detection guys. And the whole idea was to push that envelope so that we can extend the inspection interval. But of course, this is 20 years ago, when the amount of digital data that was being acquired was very, very limited, and we were bounded by one number, the 1995 crack size.
Yeah.
Now we
Yeah.
have more.
Yeah. And something like that seems to be happening in the oil and gas industry. You see that with there's quite a few companies now offering inspection services with true digitalization, right? And I've seen a trend in this both in aerospace and in-service inspection, where the analyst is remote. The analyst might be in several time zones away from the technician who's actually collecting the data. But it's kind of a singular sort of disconnected silo. But now with oil and gas inspection, you're seeing they have these huge campaigns where you have to shut down a refinery, and many companies are involved, many inspection technicians, different modalities, right? Different ultrasound and RT and eddy current, stuff like that. And then all that data goes somewhere. And there are companies, now entering the field who are offering to manage that data and manage the inspection campaign, right from planning it to executing it to then aggregating the data. And I think that's the magic word, is aggregating all of the data from the eddy current, from the UT, no matter which company was in the field collecting it. The asset owner wants it, and they want somehow to interpret it. And then make predictions, as you say. Could they reduce the frequency of inspection in some areas, or based on a meta-analysis of all of this aggregated data, should they be increasing inspection frequency in some areas? And usually you only find out about that after there's been an event, right? Some sort of failure and a loss of containment, and then it's big and it's public, and people go, okay, well, clearly we have to increase the inspection frequency of these types of components because they're susceptible to this damage mechanism that we hadn't predicted in the past. So maybe now with the ability to do big data analysis and the ability to aggregate data from multiple inspections of these kinds of assets, we can do better prediction. And I think that's exciting.
Dave, you brought up an interesting thing. The fact is that there are engineers, good engineers, people like you, who can see all these possibilities.
Yeah.
And you struggle with industry adoption, because industry will adopt when there is a big news item. It's not that we learn after the news happens. It's just that we accept the solution after there's a sad episode.
Yeah. And that's human history, right? From when we started piling rocks together to make houses. You learn to pile the rocks better when the house falls down. Yeah. So, it's human nature.
So I think we discussed now a lot about NDE 4.0 and a lot about digital transformation. And I also see that the biggest value, the biggest use case for NDE 4.0 will be coming up in some future. But a lot of people are asking, okay, why should we be discussing this now? And it's still 5 to 10 years down the road. And what does it have to do with me and me being an inspector? And I think, Dave, you created an interesting wording, NDE 3.5. And in my eyes, NDE 3.5, that's really digitalization to support NDE. So what, in your eyes, are the biggest challenges you were seeing implementing NDE 3.5 or digitalization for your customers?
Thank you. So you're kind of responsible for the whole NDE 3.5 thing. So you and Ripi have been talking about the digitalization of NDE for a long time, and the fact that NDE 4.0 is coming and you need to prepare for it, and here are some fantastic things that it will bring you if you are prepared to evolve. but people would say, well, people who are at the NDE 3.0 level, right? They have computers running inspections. They still have human inspectors setting it up and human analysts looking at the data, and they're going. I don't even understand half of those words. What's the industrial internet of things? What do you mean by big data? Isn't big data bad? Isn't that what Facebook uses to sell me stuff? So yeah, so we sort of decided that NDE 3.5 was maybe a little bit less scary because it didn't require this big a vision, and it's a manageable chunk to move from an isolated computer system running an inspection directed by a human to having something that's slightly more connected. And most of the people who are adopting it, like the people that we connect with who are adopting it, are in manufacturing, because manufacturing is always about automation and high speed and get the stuff out the door because the demand is huge. And we are having, as you know, there's a demographic problem with NDE right now. People are retiring, and the recruitment is difficult, and the training period is long. To develop the expertise takes years. So people are looking for ways to make better use of the technicians that they have available and the analysts that they have available. So automation is the key, right? To make a technician more powerful, you have to automate all the tedious stuff. And that's where we're seeing people are getting excited about NDE 3.5, right? Take procedures like setup and calibration and even simple inputting of data, right? We have barcodes and QR codes now. There is no reason for anybody to be typing serial numbers into a keyboard, right? Absolutely no reason at all. It is a waste of human life to make someone do that, right? They should be.
And it's dangerous.
Yeah, you could make a mistake, right? And you cannot detect the mistake. That's the real point. You can make a mistake with a human typing a serial number, and you can't detect it. So, at least with a laser barcode reader or a QR code reader, the machine will tell you, I can't read that. I don't know whether that's a 5 or a 6, right? But a human would squint like me. I would do this, and I would go, yeah, that's more likely a 6 than a 5, and I'd type it in, and I'd be wrong, or I could be wrong, right? I have a 50-50 chance of being wrong. So having a computer read a barcode is the right way to go, because if you want the traceability of that data, and you care about the serial number, and we do in things like high failure, high penalty for failure industries like aerospace and power generation and oil and gas. You care about the provenance of the thing, and therefore you have to care about the provenance of the data about the thing. So then you should be automating all that stuff. And that's where we're getting a lot of enthusiasm from people is, can you help me reduce the amount of tedious, useless work that humans shouldn't be doing? And so, can we just look up the part identity in a database? Yeah, that's easy, right? That's an SQL query. And if you don't want us touching your database, that's fine. Dump it into a shared folder as a text string or something like that, and we'll read that. But there's many ways to transfer data between a corporate network, an NDT system, and then when the NDT system is done, they can report their status, right? The fact that I have this part, serial number XYZ, and I'm about to inspect it, or I have inspected it and it's waiting for analysis, or the analysis is done and this part has failed and it needs to be quarantined. And that's a really big thing, the idea that the part has failed for some reason. It doesn't necessarily have to be defective. It just has to not meet whatever your quality control criteria are. And then every other machine in the factory knows that part should not be worked on. So if you have connection to a database, the next machine, like let's say you're machining metal or something like that, and the chunk of metal comes down to the machining center, and the machining center looks up the barcode and says, what am I supposed to do with this? Am I supposed to, make it into a disc or a turbine blade, or what am I supposed to do with it? And they'll get a red flag saying you're not supposed to be touching that material at all. It's been quarantined. So that level of guardrails around making sure that defective material gets no further than the first time you detect it.
So when
is big, yeah.
So when it comes to digitalization of data, we sometimes tend to think of it as one kind of digitalization versus another kind of digitalization. I think it has been. I'm sure others have said it, but Dr. Doug Mayer, who's the architect of our platform, put it the best, which is in NDT, I think in general as well, but in NDT specifically, there is three kinds of digitalization that can happen. There can be a structured digitalization, which is structured means it's a very well-defined database where all the information is going, and then you go and you run queries and you find things from there. There is the semi-structured digitalization, and when it comes to semi-structured, it's the I guess it's the analysis itself that was done. The analyst has gone and basically made a few calls and said this is of this kind and so on and so forth, but they're still picking from a list. It is not necessarily going into a database where it's saying it's a delamination versus resin starvation and that particular column is ticked, but rather it's something where an option is picked. So this is semi-structured data. And then there is the unstructured data, and unstructured data refers to things like the analyst going and marking annotations on the part saying, this is weird. I don't know what's going on here, but this is something we should look at. I don't think this is good enough to trigger a retest, but let's watch out for this stuff. And then comments that they leave in there, those are things that are unstructured information. And when it comes to digitalization, it's not the action of digitalization itself, at least from the manufacturing sense, or in manufacturing facilities where it's lacking. I think it has already started a long time ago. It does exist, but it is more on the type and quality of digitalization that has happened. A lot of things live in Excel spreadsheets, and good luck finding it. Well, finding the spreadsheet to begin with, forget about the information that was noted down there. So we slowly have to start recognizing, and I think we are starting to recognize the fact that it's the use of the stored information that is of the most importance. And when we start using it, the very first step is to accept the fact that not everything can make it into a database and can be queried on as and when you need it. So I think we are at that next stage here. I think not even 3.5. I think we are more like 3.7 now, as we were talking just before we started streaming live. I think the NDE 3 to NDE 4 and beyond is a continuum. We are basically not doing discrete steps of jumping from one level to the other level, but rather we are slowly getting to a point where we can say, yeah, I think we have reached NDE 4.0, and now we're talking about the next steps here.
Now, Abhishek, I have to say something very shortly, and that's more to terminology, and this is just because me and Ripi have been spending the last 2 years working very intensively on the words digitization, digitalization, and digital transformation. What you were referring to is actually digitization. Digitalization is the simplification of isolated tasks or isolated processes using digital data. So it's digitization is the conversion from analog to digital. Then you go to digitalization where you use that data, and then you could come to a digital transformation where you connect multiple systems so that you do not have to copy over data from A to B to C to D anymore to do that. And I will be putting, for those who are interested in the terminology, I will be putting a paper in the chat so that you can actually look it up. But now back to the topic of digitalization, and perhaps coming back to that question. Now, what was the biggest challenge when facing customers and discussing digitalization with them? What was the biggest challenge you saw convincing them or whatever it was?
I think they were all on board of digitalization. I think I'm too young to think in analog. So digitization is taken for granted. So I think digitalization is encoding of information from I guess paper into something useful, something that people can use in determining how a particular process needs to be changed so that you don't see any more defects. So that's what's digitalization, the way we look at it, and I think it's not as much as convincing the user, at least in the manufacturing space, that they need to digitalize, but rather what is the type of digitalization we are doing, and how can we eventually use that information in a meaningful way. So I think we're already at a point where nobody really wants things to live in emails or in reports that are printed and put in a cabinet. Like those days, not in service. I'm not talking in service. Those days on today's manufacturing shop floor is long gone, and it's being driven predominantly by Industry 4.0, because the production and the data collection, or not the production processes have already seen that transformation, or at least they're far ahead of where NDT stands, and I think I think it's the quality that we're talking more than in terms of whether we do it or we don't do it. It's how we do it is where most of the discussions are.
I agree. I think it's, Abhishek mentioned his youth. He's not as young as he thinks he is. So I'll explain why I'm roasting my favorite colleague. The Canadian Institute invited me to give a guest lecture a little while ago to their graduating NDE class. And we talked, my whole topic was about digitalization. And these are all young people in their 20s. And they were shocked that you could, go somewhere and go to a place that had a roof and bricks and a door and purchase a thing that was manufactured and hand over another thing, a $20 bill or whatever, to purchase a physical thing. They sort of grew up in true digital natives, right? If you want to read something, you click a button on your browser and it shows up on your phone, right? There's still a physical thing. The phone is mediating with a server at your bank to transfer electrons to a server at Amazon. And then, the novel that you want to read or the textbook that you want to read shows up on your phone. And so, that's, to me, that's true digitalization. They hadn't even really thought too deeply about the fact that that's the new way of doing things. And the old way is still around, but it's not something that they have experienced, right? So when they were 5, their parents read a book to them. But now everything is on the phone. Everything is electrons. And I think it's true. In-service inspection is rapidly adopting digitalization, right? So the job assignment is digitally mediated. It's sent to your phone, right? You have an app that says, go here and inspect this thing, and the company will be paid electronically, and you'll upload your data, and an analyst will make an assessment of it, and then the analyst will upload their assessment or their judgment digitally. So it's rapidly happening, I think, in in-service inspection as well as in manufacturing. We're perhaps just not aware of it. And I think the adoption is going to increase because of this demographic shift that we're seeing in non-destructive testing industry, is that more and more young people are coming in who just don't want to deal with old people technology, right? It's so last century. So I think as that happens, the pace will accelerate. You asked what have been the challenges for us. It's not so much in getting people interested in moving from a sort of isolated NDE 3.0 system to something that's more integrated. It's perhaps in managing expectations. There's sort of a historical thing with NDE. People don't want to spend money on it because it's something you have to do, not something that you want to do. So there's a perception that this is a cost center, as opposed to realizing that there's tremendous value, competitive advantage to have more information about your material, to be able to predict better, to be able to push information back upstream to manufacturing, to say, hey, we're starting to see, more indications in this region. Is there something wrong with the tooling? Is there something wrong with the material or our selection of the material? All that kind of stuff, right? That's valuable competitive information that you can extract from your NDE data, if only you had the ability to do that, right? And that's where these steps to integrate into your factory database so that the NDE can happen more quickly and at lower cost. And once you've done that, when you're doing a thing more quickly and at lower cost, and then you have this benefit of this information that is then, as Abhishek said, the data means different things to different people, right? The financial people who are trying to predict the sales of the company want a whole different thing than the people who are designing the next generation manufacturing for that material or that product. Everybody wants slightly different information. But if we can put it into a format where everybody can have access to it, and people have built tools to extract information from the data, and then you get knowledge from interpreting that information. I think that's the real magic of moving from NDE 3.0 to 3.5 and eventually the NDE 4.0 is that you reduce the cost of that knowledge, right? Getting at that knowledge becomes cheaper and easier. Therefore, you'll start to see the benefit of building the tool to acquire that knowledge.
Ripi, I know you have been doing a lot of coaching and consulting of companies on their way to digitalization and digital transformation. From your view, what did you see as their biggest challenge?
What I see is that, over the last 3-4 decades, this whole mindset of lean and continuous improvement has built in this thing about small activities, small investments, small instantaneous benefits, right? When you think about innovation, which is a little bit larger step, and when you want to think about transformation, which is, where you can't even recognize where you were before, people can't see that. And they actually don't want to see that. They don't want to take time to realize that there is so much power possible if you take a step back and plan it out, and then do your digitization of equipments and digitalization of processes in a well-defined manner, in a sequence where at the end of the journey, you get to your destination much faster, much cheaper. I mean, they would rather do quick hops and go here, all over the place and get somewhere, because I just want to do something now and get the result now, rather than find the fastest path to a good destination, right? We all recognize that 3 to 4 is not a single step. It will go through whatever you want to call it, 3.1, 2, 3, 4. You can go to second decimal place, third decimal place. You can put a 0 to 100% scale. But the example I often give is, when you build a house, you actually go to an architect and you design the whole house, and then you start building the house. But the way I see companies doing it is like, father is building his room, mother is building his room, kids are building their room, mom's building the kitchen, and everybody's building their own thing without the map of the whole house. And then they're saying, my bedroom doesn't have a door, it doesn't connect over there. That's what they will have. And then they will get into repairing and fixing. And then they will say, we should have thought of it before. Yeah, well, yeah. I mean, you never start building a house without an architectural plan. Then why do we start building a transformed business without a proper plan? That's one struggle that I have. It's basically the mindset of lean thinking rather than innovative thinking that blocks them from actually seeing a distant future and planning it out.
I think you're right, and specifically in the case of NDT, it's always seen as a cost center. Everybody thinks that NDT is just this cost that you have to incur because otherwise the regulatory bodies won't let your parts through. Nobody thinks of it, or I hope people are going to slowly start thinking of it as a mechanism of doing cost savings, and not as where the cost saving needs to happen. A lot of manufacturing facilities that I have visited, they have systems running for the last 10, 15, 20 years. Very recently, I was at one such facility training a group of people on the new system that was using stuff we had done, and one of the operators in that training session was running the system right next to it, where he was watching a blip on an oscilloscope, and it was a perfectly fine system for their needs, but they did not feel the need to upgrade it, to spend a single dollar or pound or euro, wherever you are, in bringing that system to the modern age. So I think when it comes to continuous improvements, I would love to see it where people spend money doing it as well, and not just trying to do the best they can. And it's usually individuals who do it because they realize how imperfect the process is, and they start creating workflows and procedures that will catch mistakes, and that will basically improve their productivity. But when it comes to investment in it, I agree with you. I think it's not planned, at least the incremental portion of it.
I think I personally now, after having coined the term NDE 4.0 in the US, and a few years later, I'm beginning to feel that that was a wrong terminology to use, because as long as you still call it NDE, NDT, it will have the same stigma and emotion that we have been carrying for the last 30, 40 years. It should have a different name, which reveals its true purpose, which is more around insightful data, or something that actually gives you a vision of the future, or something that is result oriented rather than action oriented. NDT is an action. We should shift the terminology to something that talks about the value coming out of it.
Yeah, absolutely. Yeah. And to your point, I also see the reverse, like unreasonable expectations. I've been present a couple of times when somebody from senior management is saying, I've been hearing about AI and machine learning. We should use that to reduce our costs, or to improve our effectiveness, or to do something. And they're not necessarily sure about what it is they're asking for and how it's supposed to work. But the buzzwords are infectious, and
I need toy syndrome.
The number of people that we met last week at Korea who wanted to say, can you help us build a strategy around AI, was surprising. These are senior people. I think they know better, but they're getting carried away. To me, you should have your strategy that serves your business objective, and then find a way to use AI to accelerate that. Not build a strategy around AI. But
absolutely. Oh no, you're 100% right. Like we have taken the approach. Don't have this clever tool that you're in love with, and then look for applications for it. Right? Figure out and that's right around machine learning. Like all of the clients that we're working with on machine learning, we kind of carefully have to manage not so much the layer of engineering around the NDE process and the data that it's supposed to generate, but the next layers of management up the food chain often have I'll just say naive expectations about what it is that is being done and what it's going to produce. And for us, that's, you're still going to need a human analyst, right? Like we are not going to make decisions about the suitability of a component on the basis of a model. The idea that we're approaching is that the tools should identify what it is. If you have a particular analysis that you want done, and instead of having a human being deal with 8 gigabytes of data, you want that human being to look at 4 regions of interest where the algorithm has detected that something is different than what you say is the normal criteria. So something about this region stands out, something about these echoes or this particular reflection stands out. Then a human needs to go and evaluate that and say, yeah, well, that's fine. It's geometry or whatever it happens to be. And then as the models get better and better, they become better and better filters and curators of information for for an expert analyst to look at. I presume eventually we'll get to the stage where machine learning algorithms will be good enough to make those calls by themselves. But that's a very, very long road. You need a lot of validation and verification, and I think people underestimate how much effort that takes. We see people only, as Abhishek said, they're only upgrading every 20 years because the process of upgrading is easy. You have us come in or another company come in, and we put some equipment there, and we install some software, and we train your operators, and we're gone in 3 days. But the process of validation and convincing your clients that this system is producing usable data, or convincing regulators that it's not going to make mistakes, it's not going to generate false negatives and stuff like that. It's a big labor and cost intensive process. And I think people think, oh, we'll just slap AI on it and all of that goes away. It doesn't. It gets bigger. And it gets bigger with AI.
I think when we start having conversations with some of our customers, the first thing we do is not use the word AI, because it's a very broad umbrella. It means a lot of things to different people, and people start getting confused with what they are looking at from the perspective of generative AI and other stuff. I think our subset is a realistically usable subset of what we're doing is more in the domain of machine learning and creating model on our data. So we basically have a lot of data. We use models to learn patterns, and then when new data comes along, we basically compare it and see if it matches a pattern or not. That's where we are. That's the reality of it. So if you want to think of it, it's nothing but a filter at this point, a filter that can be used to help the analysts, not to replace the analysts. And when we talk about helping the analyst, we're going to make a good analyst better, but unfortunately, it won't make a bad analyst or an untrained analyst any good at doing their jobs. So that's what machine learning models are, where we are using them at this point.
Yeah.
Johannes, are we getting any questions from the audience?
Yes, we are.
I think we should get
I have
to
a
that
couple of them.
Yeah, we should get to those.
Yeah, so let's see. Let's start with the ones about AI, because this is the topic we just started discussing. So, AI and machine learning can be adequate tool for screening, and giving the customer an advantage is just taking the words of, I cannot read this. There is some icon on top of it. I'm very sorry. That's technology. I have to move this up.
That's AI determining you. You don't need to read it right now.
Okay. Artificial intelligence, machine learning can be an adequate tool for screening, and giving the customer an advantage is just taking the words of the text.
I'm not sure I understand the comment.
Me neither.
I see.
So.
I want. Sorry, this is a subjective interpretation, but maybe they're saying that a human analyst will look at something and go, "Yeah, it's fine. Like, it doesn't meet certain criteria. If you squint it, it's not 6 pixels long. It's only 5, and therefore a human's no more reliable than an AI or a machine learning algorithm." Yeah, but I go back to the barcode reading thing. The algorithm will report its confidence, and the algorithm will report, over time, the metadata around that algorithm will say, some percentage of our calls are overcalls or undercalls and things like that. There's a lot of data science on in the background to put guardrails around what it is that you're asking the machine learning algorithm to do. So I would say that in the same way that human beings have guardrails, like you have to be a qualified analyst, right? You have to be an NDT level 2 in a certain method, whether it's RT or UT or whatever. And then you have to have presumably employer-specific training or mechanism or procedure-specific training. So I think all of those are the guardrails that we use to make sure that human analysts understand the limits of what they can and can't do. and their obligations around reporting indications there, or those levels, reportability versus rejectability and things like that. And yeah, obviously those same mechanisms need to be built into it, and an artificial analyst, if you will. A machine learning algorithm has to be able to report its confidence, and it has to be able to report using rules that we have put in place.
So computers are really good at finding patterns. And our approach has been to find patterns and put them in a table and make suggestions to the analyst. The responsibility of making a call on what it is and should they be concerned or not, that is still on the analyst. I think they're the best place because they have contextual information, like Dave was mentioning, in terms of training, in terms of their part, in terms of the process it has gone through. So all those things combined determine and how a call is made, and that's not what is recommended at this point. I think that is still definitely in the human domain. But yes, we can help sweep through gigabytes of data and make a table containing 50, 60, or 100 potential things that have meta criteria, whether it is a learned model, like a machine learning model that has done it, or if it is a statistical model that has come up with that information. But definitely putting that information in front of the in front of the analyst is what our role is, not to actually call it one way or the other.
As of today, I think eventually, very soon, time will come when the calls are very obvious and things are pretty black and white. The machine could make the call, so that you relieve the analyst of doing 70% of the things which are still off. Why do you have to ask me about this all the time?
Yeah, we actually.
And then as the machines get smarter, that gray band can get narrower and narrower.
And I think for me, it's also really important that we implement all the reliability measurement tools. We all know about POD, how important POD is. And I think in my eyes, the more we go towards automation, the more we need to show how good those computers are. But that is actually the surprising part. On every AI solution I've found which was implemented up to the moment, the reliability of those AI solutions is mostly way better than what the human inspectors are doing. And also usually this with that a lot of companies are also very concerned that the computer might be tagging more components as failures than what we are currently doing. And what I found out, if people are doing a real approach to AI, doing it seriously and doing all the numbers correctly, they find out that actually the algorithm, or using the algorithm, you can reduce your scrap rate. So it becomes a business benefit doing it just from a scrap rate point of view. And for me, that was very surprising because I always thought, okay, yes, the scrap rate will go up a bit. No, it doesn't. So I think there is a lot of benefit, and perhaps at some point we will come to the point of what's the risk of actually trusting the human?
Well, I think we're not there yet. So because we have spent time, and there's an entire team at UTEX that works on this stuff, time in training the model, and in some cases, it looks pretty surprising. It looks pretty good, but honestly, we ourselves have not come up with the criteria that can say how good a model is. I think that is still a work in progress. Yes, in certain cases, it might say, oh, yes, it found more than what the human analyst found. But that's where we give it as a tool to the human analyst, because that's who the FAA is going to trust. FAA is not going to trust, some guy who came up, trained model on, a few thousand data files and says, I know better than individuals who are experts, like in Ripi's case, in fracture mechanics and analysis, and basically say, I know more than what Ripi does. I do not think any regulatory body is going to accept that at this point. Just look at self-driving cars, for example. There's been billions of dollars poured in, and some of the best minds, human minds, have been working on it, and yet it's not on our roads. So, and NDE is a much smaller sector. So I think we have to be conservative in how we get there. Yes, we will. I agree with Ripi and you that there will be a point when this will do a lot more. But I think that's still, I think we still have to work towards it. I think we are at the stage where we are working on building it.
Yeah, we're at the beginning of the beginning. I agree with Abhishek. You know, and we, you know, we've talked about a computer programmer and an analyst. It's a much bigger team, right? Like there are fracture mechanics people, there are material science people, there are big data analyst people, there are process experts, there are regulatory experts. There's a vast community of people who decide to deploy something like this, right?
There is actually one more question to one more player. How do you see disruptors like Gecko Robotics or UT drone manufacturers impacting the market and regulations?
I think it's great. I've actually seen a presentation recently at the management conference, and Gecko Robotics did something on 3D 3D visualization, and it's huge, right? So they demonstrated using a drone with 3D spatial coordinates and using high resolution digital imaging, so 2D imaging, right, camera imaging, and then reconstructing that into a 3D model of a structure like a bridge. So, you know, for example, we were talking earlier about driving down the cost of NDT. So to inspect a bridge like that, you would have to have, you'd have to close parts of the bridge. You'd have to have a barge in the water. You'd have to have cranes. You'd have to have, you know, all kinds of infrastructure. So the cost of doing that is huge. But if you can have a single person drive up in a pickup truck, deploy a drone, fly it around for a few hours, upload that data, and then have high resolution images of you know, to the point where you could measure bridge deflection and things like that as big vehicles pass over it. So you get a much better, I think, a much better view of what's going on with that structure than you would from having an army of humans crawling over it.
I think I would like to add to that question. I think we would like to see more disruptors. I think too many people and too many companies have been too comfortable for too long a time to basically recycle, you know, 30, 40, 50-year-old technology. I think I would love to see more disruptors. I think, great job, Gecko.
I totally agree with you. And we need disruptors on a digitization level, where we see new ways how we can actually measure stuff. We need new ways on how to work on processes like drones, like robots, like AI, like whatever. And we need guys who are building the infrastructure so that in some future we can just hook up all of our computer system and they talk to each other without having to do the job. And I bet there is more to it, and we need all of them. And for me, it was always NDE 4.0 is not what one person can do or what one company can do. It needs the community. It's a community effort.
Yeah, absolutely. Very collaborative. Yeah, there's a comment here I see from Tobias Scouch at about manufacturing centers, about asking, you know, can you use the NDE to dictate to the machining center to machine away the defective regions if it's a complex part like a turbine disc. Yeah, that's already happening. Not in a real-time way, but clients of ours are already doing these three-dimensional inspections using ultrasound and merging the data from multiple angles of inspection, and then, you know, finding the location of indications in 3 dimensions, and then deciding, you know, if you have a $500,000 hunk of nickel, are you going to spend another month machining that, and can you machine away the regions that are of concern, or can you, or do you have to scrap a $500,000 worth of nickel? So yeah, that's already underway, and like you say, it's a collaborative effort between the people who program machining centers, the people who do 3-dimensional modeling, in SolidWorks or whatever platform you're using, and that all speaks to data interoperability and the ability to manage your metadata really about the results of the inspection and what to do with it next. So it's not a, earlier I mentioned an example where it's a go no go decision. You've rejected a part at the ultrasonic inspection and therefore it should not go further. But there's a spectrum there. If it's a big expensive part, you might be able to repair it and continue, or you might be able to index the machine in such a way that you're not using the material that may be defective. Yeah.
So I have one last question. How do you see the UT market growing compared with other NDE techniques over the next 5 years?
I think it is not a one versus the other. Different techniques. If you think of it about it from the physics perspective, they interact with a component in a particular way and give us information about the part under test in a particular way. As time goes on, a lot of non-contact techniques are being developed. One of them is microwave. There's terahertz imaging. There's all kinds of new techniques that are coming that are becoming, well, normal, if we want to put it that way. So it will never be a one versus the other. If it will be a first level of inspection to see, do I really care about looking at it further? I think if this says it's good, it's good. If I find even a small signal that says, oh, this could be of interest, just take a closer look at it. Then you go ahead and you inspect it with other techniques. And we see it within ultrasonic inspection itself. If you, I know we mentioned about 8-bit, 12-bit, 16 and 32-bit data. But the data banks that need to store this data exponentially have to grow in size as we increase the amount of data that we are collecting. So what is generally done is in the manufacturing space, you would go and inspect at a generally acceptable resolution level and look at the data. And then if something is found, if it says, oh, there's something that you need to take a closer look at, it's like the doctor ordering extra battery of tests, and you go in with a phased array probe with a much finer resolution. You hit it with waves at different angles and so on and so forth, just to characterize and learn more about the indications. So I think it's it's not going to go away, or it's not going to increase. It's just going to become or blend in this space of information coming from different techniques and sensors.
I agree. I think it's going to like all methods are going to grow as we begin to switch to a solar and wind, and we're going to have oil for a very long time, I think, because there's parts of the oil industry we just cannot do without. As we build more wind turbines and as we build solar cells and things like that, and then all of our infrastructure, the longer it ages, the more ultrasonic inspection, the more X-ray inspection, the more visual inspection it's going to need. To return back to that Gecko Robotics example that somebody mentioned, right? Their disruptive tech of doing this three-dimensional visual inspection imagery might reveal to somebody, hey, it looks like there's rust on this section of a structure, like a bridge or a pipe or whatever. Okay, so then you drop that drone and you add an ultrasonic probe with some couplant, and the drone flies over and does some spot checking. I've already seen an example of that. I think I forget the name of the company, but Paul Holloway's YouTube channel, Holloway NDT, they did a demo of this drone flying up on the side of a oil and gas structure and doing spot checking of wall thickness. So, like all those kinds of disruptive technologies are merging together. And I think that's really the big thing about NDE 4.0, that there are enabling technologies, right? We're better at computing. We memory is so cheap as to be almost a non-factor. We now have the computing power to use algorithms that we had in the 1960s for doing machine learning. And we knew how to do this, but we just didn't have the computing power, and now we do. So all of those enabling technologies, right, the ability to have remote control drones that can use GPS signals and fly themselves. They don't need a human operator to tell them where to go. Well, all of those technologies, I think, are gonna collaborate and work together the same way that we as humans collaborate and work together. And in general, I think it's for all areas of whether it's manufacturing or whether it's infrastructure, I think all areas of NDE are going to keep growing and expanding. And the more we drive the cost down, the more areas then people will think of NDE as a viable method of checking or providing quality control.
I'm with Dave Seto on that one, because I think 30 years ago we started talking aging airplanes, and now we talk about aging bridges and aging railway tracks. And as the infrastructure gets old and there is not enough money to rebuild or replace, there will be money going into maintaining and extending life. So the total market of inspections itself is going to grow, and then every method is going to grow.
Yeah. Hey, pretty soon we're going to be talking about aging spacecraft. Right? we have reusable spacecraft. That's not something that we had 10 years ago, and now we do.
Yeah.
So yeah.
And look at all our infrastructure. We have bridges which are now becoming old. We have nuclear power plants which are becoming old. We have whatever. And in my eyes, it really depends on, if you really want to know how quickly UT will grow to other methods. I think one factor which will really drive how quickly a method is developing is how quickly the industry is adopting to the new requirements which are coming up.
Yeah.
If we give the customers what the customers want to have, and that is the customers want to have eyes and ears to their products.
Yeah.
They want to have eyes and ears to see what is the quality. They want to have eyes and ears to see what is the problems, what is it that we have to improve, what is it that we have to change. And if we give them that in a way they can easily use, then they will start doing it more and more. A couple of years ago, no car manufacturer was doing any NDE. Now about all of them are doing it. A couple of years ago, no bridge manufacturer was doing any NDE, and now all of them are, or they're slowly getting into it. And it will be more and more coming to the point that we need those eyes and ears, and whoever gets there first will be. And also, we have to differentiate which components. For some components, you can do a UT, for some you cannot, and for some you can RT, and you cannot do it for others. So there's also that. But I think this is something where how we can expedite it is really to see, okay, how can we give the tools to the people so that they can use it easily.
Yeah, for sure. Yeah, and integrate the tools so that you don't need to be an NDT technician in order to take advantage of NDT technology. There's a company in Windsor that has real-time ultrasonic spot weld checking. It's built into the spot welding. So as the weld pool is being formed, there's an ultrasonic signal, and there's some smarts in the background that are telling you that the spot welder is doing its job, or the spot welder needs help, right? Maybe an electrode change or something like that. So there isn't an ultrasound technician there looking at the spot welds, right? There's an algorithm. So the engineers who are in charge of an automated manufacturing line are taking advantage of some very sophisticated ultrasonic inspection technology, but it's built into their welder. Yeah, it's really exciting. Yeah.
I guess we have to come to an end. We are already about 27 minutes over our time we originally wanted to discuss, but I think it was a fascinating discussion. And this is, I think that I am looking forward to that future. And last week when I was in Korea at the WCNDT, there was also, Ripi said somewhere, I think it was in 2018, he said, in a couple of years, there will not be any more an NDE 4.0 session, but every presentation will have NDE 4.0 within it. And I think we're already halfway there, because about 50% of the presentations I saw were all about NDE 4.0.
Yeah.
So I think all of us, I think we saw it already back then, and I think we all will still continue working on it. So any last words before we close the session?
Thank you. This was fun. Yeah.
Well, thank you for giving it a name. I know Ripi mentioned that he wished he hadn't called it NDE 4.0. But sometimes when things have a name, they become tangible, they become real, and people start talking about it and investing in it. So, no, that's I think that's pretty good. Yeah.
Thank you, Abhishek. I had no clue when I first introduced the term at the ASNT 2018 Research Symposium, where I was invited to talk about innovation in NDE.
Yeah.
And the term came to the mind. I presented it. Later on, I discovered that Norbert had already used it in Singapore about 9 months before I did it, but no one in the US had heard of it at that time. Lo and behold, 6 months later, as an invited talk, and it just picked up. But here we are. So thank you, Johannes, for putting this together and combining two of your passions, UT and NDE 4.0. I'm glad you didn't call it UT 4.0, but this is good.
Well, that is potentially a thing, right? I agree with Abhishek, Ripi. I think that it's a term that is necessary at this stage of the evolution, right? Like to help people wrap their mind around what's going on. The fact that it relates to our fourth manufacturing revolution and the integration of our processes, and that it's a good thing if it's managed properly. Like all technology, it can be misapplied by ignorance or by usually by ignorance. But I think that it's a really nice way to package it. So I'm glad you and Norbert came up with the phrase, and then we're gonna ride your coattails and from NDE 3.1, where some of us are, to all the way to this digitalized future where it's exciting. So exciting times.
While you plan for 3.1 and 3.2 and 3. Think, visualize 4.0 before you go to 3.2 and 3.3.
Oh, what, we can't build the roof of the house first and then figure out how to put walls under it?
Exactly.
But that's kind of what's happening, right? People are saying, let's use AI. That they're putting a roof over something called AI, and they don't have walls or a foundation yet. Yeah,
exactly. I want a massive screen TV bought first before I even think of what the house will look like. Because
build your house around the TV. Haven't you done that?
That's a thing. That's actually a thing. We talked to some smart guys from Marietta NDT, and they do offer that as a service. So when you build, like let's say it's an aerospace company, right? And you're going to build an RT system or a CT system, that's a huge machine. So you have to design the facility around the machine. You have to serve the machine, which means, and you also need to bring, let's say it's aircraft or aircraft components. You got to bring them in and out. So you're both right. Like Ripi's right. You have to design. You have to architect. You have to have an architect design the facility, but the facility is designed to serve, CT inspection of large aircraft. So that's a service that they offer. They will help you engineer the structures and the infrastructure needed to support that NDE process.
Yeah, but even then, you defined the purpose first, then you did the architect, then you did the construction, and that was the purpose, not that you first bought it. And
yeah.
Even that I love this discussion. I think we should be coming to an end.
Okay. All right.
All
right.
So thank you, gentlemen. Thanks to all of you out there for joining us. We had, I think, a very good viewer, and most of the people stayed for a long time with us. So thanks to all of us. And if you haven't done it, now it's the time to click on that subscribe button and click on that thumbs up button. So see you soon. I hope I will be able to do some videos this soon. So I keep you posted. Thanks and bye.
Thank you all. Bye-bye.